Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Infinity and Beyond. It's a medium problem. And just to give you guys a heads up, I myself didn't really like this problem. I feel like it's failing to really ask the person what it's trying to ask. So yeah, that's my view on the problem. So you guys can pause right now and go over the problem once. So basically, it's a math problem where it's trying to make you think of mapping functions, and the sets that we've been given are of infinite size, and we have to be smart about thinking of a particular function which will be suitable for the given subproblem. And we've been given three subproblems basically in this Brainstellar puzzle over here. So in each of the three problems, we have been given a hotel which has one floor with infinite number of rooms. This basically means that we have an infinite set, right? So, and this set is, by the way, countable. Now, what do we mean by countable? Countable sets are basically sets that you could count on your fingers. So like one, two, three, four, and so on. So this is a set of all the natural numbers. This set of natural numbers goes on to infinity, but it is still countable, right? So for the first case, since we need to just create one new room, right? Because there's only one new customer. Basically, we've been asked a function where we map a set of infinite numbers to a new set of infinite numbers. And this is pretty easy, the first one. Basically, one solution is, and this is the solution given on the website, is for each room number k, you ask the person to now accommodate room number k plus 1. Now, what happens is the very first room, the person in the first room goes to the second room, the person in the second room goes to the third room, and this goes on for however many number of people there are in the hotel. So this is a proper mapping for the given condition, and what ends up happening is the room number one ends up being vacant, so the new customer can go and basically reside in room number one. So for the second problem, the question is, what if infinite number of people want to check in? How would you accommodate them? So in the first case, we would just to add one more person to the set. Over here, we have to add an infinite more number of people to the hotel, right? So we now have to think of a mapping where we can create an infinite number of new places. So the solution given on the website for this is basically for each room number X, you ask them to go to room number 2X. So we're mapping X to 2X. Now what's gonna happen is, so person number one is gonna go to room two. Room the person in room two is gonna go to room four, and this is gonna keep on going on. Now what you're gonna notice is now room two is occupied, room four is occupied, room six will be occupied, and so on. All of the even number of rooms will be occupied, but all of the odd numbered hotel rooms will be vacant, and those odd numbered rooms will be an infinite set. So we managed to create a mapping of x to 2x where we started with an infinite set x, and where x basically denotes each value within the initial set, and we mapped it to a new set 2x, and in doing so we created an infinite more number of rooms within this 2x set, so that each and every odd room within that set would be vacant, and we could accommodate all of these infinite people in those odd rooms. So coming to the third solution, and this one is a bit tough. Basically, we've been given an n cross n set, right? Since it says we've been given an infinite number of buses arrive at the hotel, and each having an infinite number of people, where n here basically is a template for infinity, right? So we have been given an n cross n set, and the problem is that we have to map all of these values to an n set, which is a linear infinity set. Now, so since n cross n is a countable infinite set, there is possible a mapping from n cross n to n, and the website gives a link to one of such mapping functions, which basically is represented by this function over here. And all it's doing is mapping that n cross n set to a linear n set. So basically what the function does is maps an I comma j pair to a linear k value, as you can see over here. So for 0 comma 0, it's mapped it to 0. For 0 comma 1, it's mapped it to value 1. For 1 comma 0, it's mapped it to value 2, and this goes on, right? And the beauty is that it's mapping an n cross n infinite countable set to a linear infinitely countable set. So here it is. You can plug in a few values and verify that this does indeed do a perfect mapping, right? And I hope you guys understood this solution, and thanks for watching.